Hey everybody, welcome to Revolutionizing Your IoT Prototype. I am Monica Houston from Hackster, and I'm actually at Electronica in Germany this week. So if you hear a bit of background noise, that's what is going on in the background here. I'll be muted in a second though to give the show to Jay Cantinwala, who is our presenter tonight, or this morning, depending on where you are. Jay is the Product Marketing Manager at NXP's Global Sales and Marketing Group, focused on mass market enablement. His most recent product is driving the GTM for the Rapid IoT prototyping kit, which you'll see tonight. Jay brings over 20 years of product and regional channel marketing experience for system level solutions. Besides Jay, we have a triumvirate of fantastic technical guys here with us to answer all of your technical questions at the end. If you don't see the Q&A right now, the Q&A is at the bottom and you'll be able to ask questions during the presentation, and we'll definitely get to them at the end, the final 15 minutes of the presentation. We have Greg here with us. Greg Kazamat is the system architect for solutions for NXP. Nick Krast is the embedded software engineer for Atmosphere, and Richard Laborde is the director of client success for Atmosphere. So these guys will help you with your questions. And Jay, if you want to go ahead and get started, I'm really excited to see what you have for us today.
Very good. Well, hey, thank you so much for the introduction, Monica, and thank you to all the participants on the call. I know your time is valuable, and we do appreciate it. And of course, thanks to my co-presenters. Today, I'll be talking about the Rapid IoT prototyping kit. I work at NXP in the mass market enablement team, and our charter is to take our products, take our solutions, and help enable the market, enable the mass market. Now, a little bit about Rapid IoT, a short intro. Well, what we're going to cover today will be a little bit of an intro, then I'm going to get into Rapid IoT Studio, and then how to create an application using Rapid IoT Studio. We'll do this live, and then point you to some resources, and of course, to the Hackster contest that we have ongoing. So I think this webinar is great timing because I think a lot of you must be interested in the contest, and we certainly have the people who can answer your questions. So a little bit about the product. Before I get started, I wanted to play a brief video, just a minute, to give everyone an idea of why we felt that we needed to develop Rapid IoT.
Jerry likes to get things done. Even as a child, Jerry's always acted on his ideas. Here's the thing with ideas. Ideas aren't always easy to bring to life and take to market on time and under budget. What if something could bridge the gap? Something simple. Something powerful. Something fast. It's time to let Jerry quickly develop and share his ideas with the world. Introducing the Rapid IoT prototyping kit. It's comprehensive, expandable, easy to use, designed to accelerate the prototyping process for IoT applications. So you can focus on being creative and developing your IoT idea. In this fast-changing world, winning requires a great idea and being the first to get to know. What will you build? A Rapid IoT prototyping kit.
Okay, so that gives everyone an idea why we developed the Rapid IoT prototyping kit. We know the IoT market is booming. There are ideas for different applications. People have their own domain knowledge, but it's very hard to actually take your idea and put it into a proof of concept or a POC. You can imagine pulling together all the hardware that's required and the software and being able to very quickly demonstrate a POC. This applies to everyone, whether you're an experienced engineer in a large company or whether you're just doing it for fun. And we don't know when the next killer application is going to come from, so we decided we'd just enable it. So what is Rapid IoT? Well, a couple of things to keep in mind. This will give you a quick overview rather than having to plow through our website. First is it packs 11 unique NXP part numbers and 20 total devices. So we have selected the best of breed. We've pulled together all the important pieces that you will need for an IoT node. So of course that starts with sensing, the analog, the processing, and of course the connectivity. And being NXP, we included security, we built it right in. We provide all the required software enablement for you to implement your prototype. That includes RTOS drivers, libraries, and even example applications, which is actually a great place to start. Instead of creating an application from scratch, you can start with an existing example and then modify it. There is an ecosystem of over 400 clipboards. Now, IoT is a broad area, and it's critical to cover as many use cases as possible with one kit. And we have to have that type of expansion headroom available. So if there is a sensor that we don't offer that's not integrated on the Rapid IoT, or a connectivity standard that you would like to have, it is expandable via a docking station, which you can see on the right, and a series of clipboards that can be mounted on the docking station for added functionality. So we've tried to reduce the barrier of entry in order to reach and appeal to the maximum number of IoT developers. The kit is paired with Rapid IoT Studio, which is a web IDE with a drag and drop based programming structure, which makes it very easy to use. You get embedded mobile and cloud app development at the same time. It's a very powerful feature. It's a differentiated feature. With Studio, users can change the kit's behavior without writing a single line of C code. So that's what helps in accelerating your IoT design. And then finally, as I mentioned, being NXP, we take security very seriously. We have a secure element for authentication, a secure bootloader for reprogramming, and crypto accelerators. The app, Rapid IoT app, comes ready to go right out of the box for both iOS and Android, and it just completes the out-of-box experience. It enables users to prototype the mobile aspects of their application right away. So think of it, think of a developer's interaction with Rapid IoT in three phases. First, you play with it with the out-of-box experience. Right out of the box, you can see that it comes with multiple different sensor options. You can read sensor data immediately. You can access different tools such as BLE or NFC. And then finally, you move it on over to Studio and you develop. So let's take a walk around the block diagram. Everything in green is NXP content. So we'll start with the main MCU, which is a Kinetis K64 M4 Cortex. We also have a wireless MCU, which is the KW41Z. Today we have BLE and Thread, and soon we will have Zigbee. You can see there is analog sprinkled throughout: power switch, real-time clock, battery charger, more I2C switches, and then we offer different sensors. From NXP, there's a combo accelerometer and a magnetometer, a gyroscope, barometer and temp sensor. And then we've got other third-party sensors, which include capacitive touch, which is a really nifty sensor to have for IoT applications, humidity and temperature, ambient light, and a digital air quality sensor, which is recently becoming very relevant out here in Northern California with the fires that we have. There's the A1006 anti-counterfeit security chip, and we even have an NTAG IC with an NFC interface. So it's pretty comprehensive, I'm sure you'd agree. It's available now. This is the part number. When we see Rapid IoT, if you actually want to get the NXP part number, it's SLN-RPK node. And of course, it's available now. This was a difficult slide to put together. I was trying to think of how do we explain what are the target applications. Well, I think instead of getting down into different application segments, the way I'd like to think about it is any place you need low power, security, sensing, processing, and easy connectivity to the cloud. Now, given the sensors we have, very obvious categories would be home and building automation and the adjacent smart cities, and adjacent to that, industrial. I've seen that in a lot of the product ideas that you've shared with us on the contest. Asset tracking, asset monitoring, these are getting to be pretty important applications. I also see a lot of applications for wearables and fitness and monitoring health, again on the contest page. But perhaps the most interesting is the use cases yet to be discovered. To give you an example, and there is actually a person at NXP who has put the Rapid IoT in a drone and is experimenting with that. So this is not quite as fanciful as it might seem in terms of this futuristic looking drone. Okay, for connectivity options, right out of the box, the Rapid IoT connects over BLE to either an iOS or Android app, and that connects to Atmosphere Cloud, from where you can get over cellular and gives you access to different clouds of your choice. Another way to connect is over Thread. In this case, I've put NXP's IoT modular gateway, but it could be a different gateway. And from there, over MQTT commands, you can access different flavors of AWS. Upcoming options will include Wi-Fi and cellular. It's a little bit about the ClickBorn ecosystem. This is by Microelectronica. And as I said, there's over 400 clipboards, and docking station integrates an OpenSDA interface and JTAG. So that is what you would use for some really heavy-duty debug. There's numerous extension modules or click modules, as the clipboards as they call them. You can see that we have put in green what's available, red is a prototype, and orange is scheduled. The Sigfox actually has just been implemented. So you can see there's different, we're going to add to the library of these clipboards that are available. And and for certain boards, we will have them available as an element in the tool library. Now let's get a little bit into Rapid IoT Studio, really interesting part. So it's a completely different way of creating of your solutions and your software. So the first thing is it's a web-based IDE, which means it's got a very visual drag and drop GUI-based interface. There's visual elements, you use connectors, and simply connect to elements instead of actually having to write the C code. Now, it's got a pretty robust library, and this includes elements, connectors, the ability to create embedded mobile and web app all at the same time. And what this does is that it masks the complexity of using different SDKs, different APIs, having to write the drivers to access different devices. It just makes it very much easier. So it's a very powerful tool. And all these elements have their own properties that are enabled when you select them. And then those properties are translated into C code in the end. If you want, you can port this over for NXP fans into MCU Expresso. So everything included, all the primary features included in Studio, sensor, GPIO, BLE, thread, etc. You can develop it in Studio and then port the code over to MCU Expresso if you so wish. Bottom line with all this is it means that you can create POC, in days, in weeks, instead of months. And you don't have to really necessarily rewrite code in C. You can if you want to, but you don't have to. So let's jump over to what the Studio IDE looks like. Now here what I'm going to do is we have the slides for you to follow along, but what I'm going to do is actually pull it up on my laptop. Okay, so I've actually got Studio already open in front of me. This is my view, but if you step back here, okay, you can see that. Let's start off with so in the menu here, this is the landing page. You can see that we have two options. You first start with a new project, or you can import a project. Then I've been playing around with different projects myself. And over here, you see example projects listed. So for instance, you have a click relay, a relay click demo, Rapid IoT weather station, out of box demo, how to blink an LED, you know, the typical things one might want to do. And if you select those, you actually get all the code associated with it. So let's just click this here, and you'll see that if you want to blink an LED, instead of writing the application from scratch, you actually have a starting point that you can use from right here. Okay. From here on, a couple of things is it's very important that if you want to receive a project from somebody, you click import project, and so you cannot really share a bin file. You have to share a .atmo version file. This ribbon over here is the main view. What we are looking at here is the element library. This is a dashboard for creating graphs and tables and reports. Here we have a device manager, and here you have easy access to some questions. So let's move on to the next. Let me show you different views. Let me open a different application. Let's go to the weather station. It could be anything, or I'll do the out of box. So you can see I'm opening this up. It's a pretty complex application. And the premise behind this is a couple of things that I'll walk you through. The first here on the upper left is this is the embedded application view. Next to that is the mobile application view. So you can see over here, they set up a nice little mobile view with a nice background. And then finally, this is the cloud view. The idea being that, again, you don't have to write any code. It's all integrated in one easy to use tool. This area here is what we refer to as a canvas. So this is your work area. You have your element toolbox over here, which gives you a choice of different elements that you can select. So for instance, there's BLE, a BLE GAT characteristic. There's basic elements such as a function. There's an interval, and you can move on down and scroll down to different sensors as touch sensor, ambient light sensor, and you can keep moving down. And you can add these as needed. So I'm not going to change this too much, but if you were to want to actually edit the code in C, you click up here to the code editor, and you can see that you see all the C code down here, which you can edit as needed, and you can, and of course, when you export it, it's your code. You take it with you as you go. So I'm going to close this window, and let's move on to something more simple. And start off, maybe let's just start off with a new project. So when you start off, let's call it, I'm going to do an ambient light sensor. So let's say, I don't know, what should we call it? Let's call it Hackster demos. Hackster Lux. Okay. Let's just go with Lux. Okay. So you can see it's loading up our project. Let's get right into it. Let's build it. So let's think about it. Here's what we want to do. We want to build a quick demo that takes sensor data. In this case, let's say ambient light sensor data from the Rapid IoT, and sends it out over BLE to your phone and then up to the cloud. And then we want to look at the results. So when you start off, it's a good practice to always first start off with an interval, which is at a certain point in time, you want to go and sample the data. The interval is set at 1,000 milliseconds, which is about a second, which is fine. Let's click back. Let's select the ambient light sensor. Here we are. Here it is. Let's select that. What else do we need? We need a BLE GAT element. Again, let's do that. Okay. And then we want, what else would we want? Well, we want to display the data, obviously, whatever the reading is for the ambient light sensor. So I guess we want like an, let's say I want an icon. We want a labeled, embedded label icon, something that looks like a light bulb in this case. Let's just make sure it's set the right way. Well, this has been set on a default to air quality, maybe the last thing I was using, so let's just go to a light sensor. And then, simple, we just hover near the interval, join it. When you get a two-headed arrow, that means you've made the connection. That means that every second it's going to access the ambient light sensor. It's going to take that data and it's going to send it to the embedded label icon display. The other thing we're going to do is we're going to also connect it to the BLE GAT characteristic. And here, let's look at the BLE GAT characteristic. We do a read. For the data type, in this case, it's always a good practice, almost as a default, to select unsigned integer. So let's just change all of them to unsigned integer. Trigger, it'll be written. Yep, that's about right. Now let's move on to the next part of the exercise. So let's see what we have in the application view. Now you can see that the BLE GAT characteristics is a coupled element. So whatever we created in the embedded view automatically pops up in the application view, because the source, of course, will be BLE data, which is coming into your phone. So you want to be able to take that data. Let's add another interval, pretty important. Right. So what we have here is at a certain interval, we will be accessing the data. Make sure it's unsigned integer. Yes, it is, because we selected it. And then after that, what we want to do is we want to display the data on a label. So we want to say, here is what it's going to look like. So we put a label. When you enter a label, this is your phone. This is the mobile application view. It pops up on the upper left as a default, always. Something to keep in mind. If you don't know, if you add something and you don't know where it is, the answer is that is where the label will first come up, is on the upper left, in case it gets busy and you're searching for it. And what we're going to do is we are going to read the data here. So in the data label, we will say, it's always a good idea to name your data labels so that you do not forget what each label is doing. So this is going to be read data, right? And then we want to, and it'll be displayed. We want to add another label, which in this case, I want to say, well, it's going to say, what are we really reading? And that's going to be, we called it, I guess we decided to call it lux. So go here, and we'll call this lux, a measure of light. And then let's do something, oh, I forgot. So now after we take the BLE data, you want to send that up to the cloud for further storage. So let's get a cloud element. Okay, let's do a cloud event. Connected to the cloud. Okay. All right, so it looks like right now what we'll be getting is we have these two labels. One of them we will name Lux, one of them will actually be the light reading. Okay, and out here, the next step, of course, will be to go to the cloud. And as you can see, we already have a cloud event, the coupled event set up. Of course, we want to store that data and access it later. So we put up cloud storage. It literally is as simple as that. And you join the two. Okay, so now in theory, you have everything working. You have your cloud, you have your application, you have your embedded part. All good? Now, just for a little bit of fun, I asked Monica what her favorite animal was, and she said her favorite animal is an orca. So I said, okay, let's see if we want to tidy this up a little bit and make it more fun. So let's add an image. Let's add an image for an orca. So I click the image icon, and now it's asking me where I want the image. I'm going to bring it down here. Let's browse. In this case, I did actually go and pick an image of an orca and make it bigger, larger. Whoa. Mouse is not cooperating with me today. You get the idea. You can expand the image. Okay, I'm going to stop playing with that. Okay, now the next step is we've got everything set up. It should work. We should get ambient light data, and we should be able to see it right here. Before we can do anything else, let's go back to the embedded view. And of course, what we need to do, you can't see it, but I have a Rapid IoT here with me. It's plugged into my, my laptop. And what the first thing I'm going to do is I'm going to compile the project. So you can see as we do that, you'll see a compile bar run along the top of your screen, which gives you the status. And we should get a message anytime saying your project has been compiled. A little patience, it'll pop up. There's a lot going on here. Taking ambient light data, pushing it to the mobile device. Project's been compiled, sending it up to the cloud. Perfect. So now we've done that. The next step is to take the Rapid IoT. I'm going to switch back here really to this view and show you one quick slide, which is how do you put the Rapid IoT into the bootloader mode. Now, actually a good practice is to follow what's in the user manual to turn the Rapid IoT over, push a button, and push the reset pin with the device that's provided in the back. But another quick and easy way of doing it is you simply press and hold the top left and right buttons, which is what I'm going to do. I just wanted to show you that. And when you do that, the leftmost LED would start blinking. And when that does, that means we have got into bootloader mode. Let's flip back to the studio. So now I'm going to put, you can't see this, but I'm putting the Rapid IoT into bootloader mode. All right. And now once it is flashing green, I'm going to download the binary onto the Rapid IoT using this program firmware button. This button over on the left is to download your source code. So you can see that it's downloading, it's creating a bin file over here at the bottom. Looks like it's done. Show in folder. So this is my, just so you get a quicker view. And the Rapid IoT will show up as a removable disk under computer on your laptop. So you simply drag and drop the bin file. As the Rapid IoT is being flashed, the light will stop flashing green and it will switch to a purple and then a blue. And then if everything works right, we should be getting some ambient light data on my screen. Just a little patience. It's still going green. It's working on getting the data. It goes through a boot up process. You see NXP and then the Atmosphere logo. And voila, I do have ambient light reading of right now 54 lux on my phone. Now, how do you, am I just saying that, or do I really have the reading? Well, let's go and take a look at it. In the table view or in the dashboard view. So before I do that, I have to provision the Rapid IoT onto my phone. Now, I don't have a camera on, so I'm going to again switch back to the slides and show you how we do that. So when we went through the USB drive step, the next step after that, which I'm going to do on my phone, you don't see it, but it's very simple. The first thing to do is you download the Rapid IoT app from your respective app store, whether it's the Google Store or the iStore. And then if you've created an NXP account, you should be able to access it right away. The next step after that, I have the Rapid IoT app downloaded. So what I'm going to do is I am going to now provision my new Rapid IoT device. The way to do this is you click on the hamburger sign and then you click on the device sign. In this case, it starts off with you don't have a widget configured. Now I search for a device. Always trash, good idea to always trash your old device if you have it. I like to do that, start afresh. And now it's searching for the Rapid IoT. It found it, and I'm going to provision it, which is as simple as clicking here. The Rapid IoT will show up on your provisioner. You click provision after selecting it here. And actually, I do have the Orca and a very nice display. Now, in my case, it's going to look a little different. I have the Orca down here, and I have the light sensor. Now, that is pretty simple. But if you want to view this in a graph, how do we do that? So I'm going to walk you through that again live. Let's go into the dashboard view. Let's close this guy out. And let's select the kind of graph. Let's give the graph a title. Let's just call it Lux. X-axis data is going to be the value.
You want it to be the timestamp. Sorry.
Oh, sorry. I keep making that mistake. Thank you. Timestamp and the y-axis is value. You can see the data started coming in already. Now, of course, you can set the parameters. You can play with it a little bit. You can do a data glance. You can do different aspects. You can do a data meter, pie chart, and so forth. But what we've really done, which is pretty, I don't know how long this took me, maybe 15, 20 minutes for something very simple. You actually have the Lux value coming in. Now just to prove to you that this is working, I have a little flashlight I'm going to shine, and I just shined it on it and it just popped right up to whatever the new Lux value is. So that is, that pretty much does creating a simple application that finishes that segment of it off. While I have you here, I wanted to walk you through a quick cheat sheet of how to save you time as you're entering the contest, where you want to go find information. So easy way to start is just go to the Rapid IoT prototyping kit, right? You can see we have different tabs here. We're getting into the resources section of the presentation now. We have an overview, which lists very quickly at a glance what sensors it has and what are the main devices. We have a Getting Started tab, which is one of my favorites, and we've broken it down as in with different sections, with plug it in, get software, build and run. So you can see each tab is accompanied by a development path, either with Studio or MCU Expresso, and then you can watch a video at your leisure on it. There's build and run, again, the same format, create, which tells you a little more about how to use the graphical user interface and the different elements, and then the library. Another important section is the documentation. So a quick and a must read is the user guide, which is actually over here. We offer more support information, the software release notes, we've got the BOM. The fact sheet is worth taking a look at for reference if you want to get an idea of what this is about. And then of course the most important part is downloading the IDE. It is right here. You just click on the IDE and download it. We also have the PCB layout and BOM, the bill of material, the casing files, lots of good information here. Maybe not so relevant right now, but if you were to ever take it into production, you might need some of those. And then of course we have different software applications for Android just available for easy download, and the SDK if you want to use MCU Expresso. So that gives you a little walkthrough on what we have for the Rapid IoT, and let me switch back to the slides. And I think we are in plenty of time for any questions. I would like to point out just two things. This is the main website for Rapid IoT where you see the videos and the fact sheet and the training. There's also the Rapid IoT community, but I assume you'll be using the Hackster community for this event. There's other resources we have. We've also got a link to Atmosphere, who created the studio for the Atmosphere resources if you want to get into more detail. And then just a reminder that we have the Hackster contest, and we are all so excited about this. So this is a chance to take your IoT dream and try and make something of it and win some prizes in the bargain. So I'll wrap it up. I think we are a few minutes ahead, so we'll open it up for questions.
Great, thank you so much, Jay. And just a reminder to everybody that the Q&A panel is at the bottom of your screen probably, so ask your questions there.
Come on, everyone. We do want to get some questions. We know you have them.
Jay, one of the questions is, can you show some of the clipboards? Could you go back to the slide that had all of the clipboards that were supported and the ones that are in process?
Sure. Certainly. I'm just trying to get out of this view. I'm not sure this really answers the question. I think a better way of finding out what clipboards are available is actually going to the Microelectronica site and seeing the over 400 that you have that are offered. Sorry, I clicked the wrong.
Yeah, just to be clear, the ones that are listed on that slide are ones that have elements available in the studio itself, so you can directly connect to them.
Great point. So there's no code needed, nothing is needed. It's simply an element. You simply connect it, add it to your canvas, connect it, and now you're accessing whatever function is provided by that clipboard.
There's also a question about the price for the prototyping kit. Obviously, if you buy it through distribution, it will depend, but $49 is the MSRP.
Yes, and of course, if you enter the contest and you are accepted, then you get the kit for free.
There's also a question about the docking station. The docking station is the same docking station that's been used in the past by Microelectronica for similar products. And yeah, Jay's got a picture of it. 2 slides back, I believe, Jay.
Yeah.
Yeah, so the blackboard there in the bottom is the docking station.
Okay, there's some questions here. Maybe we can read them out and have and have them answered. Somebody asked, what about security? Greg, would you like to take that?
I was answering some of the questions. Sorry, I'm typing slower, so let's read it. Yeah, so security is a pretty broad topic. I would say that your requirement will depend from the kind of applications that you are targeting. When we developed this product, we targeted the end node application connected to a phone or a gateway over Bluetooth or Thread. So the way the device is secured is first in its internal memory, right? There is some protection on the device that checks the integrity of the firmware. When the device connects externally, there is another security that starts, which is a secure element that will exchange some certificate with either the phone through the phone app or with the gateway if you are connected over Thread or Zigbee, and that will authenticate the device. You will be able to change the certificate afterward. For the prototyping tool, we program the same certificate for every board to make sure that they are genuine. So if you program the wrong certificate, basically it's not going to be paired. It will be rejected by the phone app or by your gateway if you connect it with our modular gateway system, which is available also from NXP. So that's for the security. We can support additional features. Some people do also tampering. So when you open the casing from the product, basically it erases the contents of that to protect your code from being duplicated and downloaded. But for now, that's what we offer: protection of the internal application and also protection during the connectivity. And you can also add some security to your application. We have an NFC tag on board. So if you don't want to have this pairing process that occur over the air when you connect your new device over Bluetooth or Thread, and there is some key which are exchanged over the air at that time, you can use the NFC to exchange at a short distance those key using contactless communication. So there is different mechanisms that can be implemented, and Rapid IoT embed the hardware and the software to implement it. Then I see another question about, could you please demonstrate communication example, MQTT with test broker? So this one will be available afterward, because like what's happening now is that we connect the board to the cloud through the phone or through the gateway. So the broker is running in the phone that makes the bridge with the cloud, or in the gateway. We will support the Wi-Fi click in the next release, and this is when we will connect directly the end node to the cloud. So for now, we cannot demonstrate it because it's not yet available. Thank you for Jay for the presentation. Let's say some developer has come to a final design with Rapid IoT and want to make an actual product. What are the next steps? So the product that we propose, as Jay explained, is not only another evaluation board, right? I mean, it's integrated, it comes with nice programming tools, so it could make it a nicer EVK or evaluation board. The board comes with free of charge hardware design files, which are schematics and layouts that you can reuse and customize for your own application and go to production with it without fees. And it's the same for the software driver that we provide. There is no licensing to use those drivers. So I would say that if you create your application, if it is Rapid IoT itself and you want to give it another name and go to production with that, I would say even that you can do it because there is no fees to do that. So if you want to launch it in another country under a different name with a different enclosure and color, we give everything for free and you can do it. Then it depends from your application. What I would recommend is that you don't change too much the radio, because this one is the trickiest one. And we provide certification for it to make sure that when your product go to production, you pass those certification without spending thousands of dollars of lab testing. Then it depends on the sensors that you will be using. We provide 8 sensing features via 6 different sensors, some motion, some environmental sensing. If you find the right sensors that you need, and maybe some that you don't need, so just depopulate them from your board, reuse the schematic and the layout, and go to production with that. If you need to add something else, I would say that it should be pretty trivial. You have plenty of signal available on the board to connect, I mean, over serial, I2C, UART, SPI, or via GPIOs or analog, the sensors that you need. But I would, Anthony, I would be just careful on not changing the radio to keep the certification. And then, I mean, it's free. You can reuse everything that we have done. We will not charge you. So I am not familiar with the, for number, I'm not familiar with the Gortel algorithm.
Hey, excuse me, Greg, before you move forward, I think Richard wanted to answer the comment on the question about going to production as well. Richard, do you have any comment on that?
No, I think Greg did a great job of answering that question.
Okay. Sorry.
So I'm not familiar with the algorithms that Nober is mentioning. We have certain library for sensing. I assume it's related to sensing. So we have what we call a sensor fusion that is being ported on SDK that will help to do like a 3D positioning. But there is like different third-party companies that provide advanced sensing algorithm for like to achieve the specific application. Our team are working also in parallel on what we call anomaly detection, and some of those algorithms will be available. So it's basically using the raw data from the sensor and be able to create some patterns that will help you to translate it into an anomaly that will be detected. So that will be available afterward. I'm sorry, Norbert, if I didn't answer directly your question, but yeah, we will have some algorithm for sensor. I got another question from Daira, which is, are the 3-click boards supported with any other board or device? I'm not sure that I understand the question. So
Richard, yeah, yeah, me either. So Daria, what?
So the main idea is that you will receive or you will buy the Rapid IoT, and the board itself doesn't require additional accessories. There is a bootloader which is on the board, unlike Exiware, so which is a key differentiator from Exiware. If you want to reprogram it, as Jay explained during the lab, just press the button, reset the board, as explained in the user guide as well, and you will be able to flash the firmware on your either wireless or application controller. If you want to debug and put breakpoints to review your code, you will need the docking station, because there is a debugger on the docking station which is not embedded in Rapid IoT. You need also the docking station if you want to extend its sensing or control capabilities with the Click module. And you can simultaneously connect a 3-click module on the docking station that can be controlled by Rapid IoT. So that's the answer that I would provide. Hopefully I answered the question. And the driver from the Click module, we will support, I mean, the major ones on the Atmosphere and MCU Expresso. So we are releasing new Click elements and new Click drivers with the time. So not everything is there yet, but it will be with in few months. But from my experience, if you go to Micro-E website and you take the Click driver, the C code, it should not be too complicated, depending from the sensor, right? I mean, or the controller. But the one which is GPIO is pretty trivial. It's just a GPIO status. The one which are featuring serial interface, basically it's a limited tweak. So it's not too complicated to reuse the driver from Micro-E and get it available for a Rapid IoT. Then, I mean, is the cloud gateway device required to network with an edge compute cluster? Also, then been testing with the NXP processor for AI ML just shown in the latest D magazine. William, I'm not fully aware about all of that. What I can tell you is that the MX6UL modular gateway that is sold also by the NXP solution team, it connects out of the box with the Rapid IoT. So you don't have to reprogram neither the Rapid IoT. Depending on the version that you will receive, I will say an update from the gateway, which is made over the air, I mean, would be recommended. And you will be able, with the phone app, which is available from the store for the gateway, to connect and monitor your Rapid IoT as well as control its actuators. So the update that will be made on the gateway will apply to the Rapid IoT, and for now you can connect it straightforward without any reprogramming from the Rapid IoT. The out-of-the-box application supports Thread, and we will update the Rapid IoT afterward to support Zigbee. So if you want to create a large node network with 200 devices, that's doable. I see another question. Is there an integrated blockchain regarding security purpose? I am not aware about that, because for security, we have different scenarios. So we may be able to explain what happened when the out-of-the-box application connects to the phone or to the gateway, and how it boots, and how the security is implementing during the pairing process for authentication. But let's say that each application will have different way to implement those security features. So we can work on something. The answer to your question is that we don't have it yet. Then there is more questions. So Dara is asking, I mean to ask, in case I would like to use the Clipboard without a docking station, power it with a battery and send the data via wiring it? Is it possible? So the Rapid IoT is not going to provide power to your Clipboards because there is some Clipboard which drive motors, and so it's the choice has been made that the power should come if there is a Click module to power supply from the adapter. So Rapid IoT has a battery; it can power itself, but it cannot provide power to the Clipboard.
Yeah, but Greg, excuse me, Greg, what there is a Clipboard, which is a battery-powered Clipboard. You know, there's a smaller, I'm sorry, I said the wrong thing. There is a smaller docking station, which is just
yes, that's what I was going to say. If you want to connect the Rapid IoT, you don't want to have like the large docking station with 3-click and the debugger. There is a kit from Micro which is called Power Pack. And on this one, you will have 4 AA battery and a single click socket, and you will have a slot for the Rapid IoT. So it will not only from the 4 AA battery provide power to the Click, but also recharge the battery from the Rapid IoT. So that's what I would recommend. And it's a big, like a remote control. So it's pretty compact. Will you give the docking station with the Rapid IoT based on the given idea? Jay, it's a question for you. I don't remember what was
Yeah, we don't provide the docking station, only the Rapid IoT kit. I think there's still plenty you can do with the Rapid IoT kit.
Yeah, the Rapid IoT itself, I think with the 8 sensing features, the LED, you can do a lot of application already. If I were you, what I would be doing, and if you want to create something that look even more like a finished application, is that rather than buy the docking station, I would create my own breadboard with a connector. We provide the schematics for this connector. I can share the connector which is on the docking station, which is also available from online. And I will create a small breadboard where I will have the connector, and I would connect directly my sensor. That would look much more compact. And if you want to get a chance to win with something which looks like a finished product, that would give you more chance. That's it. I think the previous question, we answered them already.
Yeah, I think we went through quite a few questions. That's good.
Fantastic. Anybody else have any last minute questions? This is your chance.
Yeah.
Thank you so much, everybody who is attending. And I'm actually going to post the link to the contest in the chat, as well as the link to Jay's slides. So you get a chance to copy that. And I'll also be sending this out in an email early next week with the link to the recording of the presentation.
Perfect. Thank you very much.
Thank you so much.
Yeah, thanks everyone. Thanks to all the attendees. Great questions. Thank you to Atmosphere and Greg for all your help.
And again, I mean, if there is more question afterward, I mean, we can still interact through Hackster.io. There is a community that Jay mentioned. I will be there to answer any question from the community.
Excellent. Well, thank you, everyone. And I guess, Monica, you can go get one of those German beers now at Electronica.
Yeah, finally, I'm excited for this. And I'm excited for making something with the Rapid IoT prototyping kit. This is so easy.
Oh, so sorry, someone has one more question.
Great.
Yes, what's the question?
You have to type it quickly, Nikhil, because there is no question. Yes, the BLE stack is included in the SDK. So when you download the SDK package, you have 2 targets. From the Rapid IoT Studio, the connectivity is viewed like a black box. We communicate with it, but we don't reprogram it now. When you go to the SDK, which is the C code level, you download the SDK package and you have 2 targets. One is K64, and that will be everything related to the application, the screen, the sensors, the actuators. You have another another folder that will be related to KW41Z, and here you will find everything which is related to the Bluetooth or Thread and soon Zigbee stacks. Can we connect Raspberry Pi with the docking station? I would say that you can connect the Rapid IoT to the docking station, and through the click headers, you can wire the signal to a Raspberry Pi 3 to the 40-pin connector from the Raspberry Pi 3. So you can indeed connect Raspberry Pi 3 through wires between both headers. Yes.
Oh, good answer.
Okay, I think we have everything.
Is there a way, okay, so first of all, your documentation is amazing, and so everyone should go watch the videos. Is there a way people can continue to ask questions if they have more questions after the webinar?
Sure, sure. What do you suggest? We can just ask them on the Hackster site, right?
Perfect, yes. On the contest page?
Yeah, would that be okay? I think that would be good. Then everyone can get the shared wisdom.
Definitely. Yep, on the discussion tab, people can ask questions there. All right. Thanks again, and have a good night or good day, everyone.
Bye-bye.
Bye.
Bye-bye. Thank you.